So today's topic is power, and today we are going to look at the relationship between power and energy. So before moving on to the details, we are going to look at the definition of power. So the power is defined as the rate of energy transfer, or it is the rate of work done. Now, the equation for power, P is equal to energy over time or work over time. So from this equation, we can say that power indicates how much energy is transferred per second or how much work is done per second. Now, what is the SI unit of power? The SI unit of power is watt. And what is the equivalent unit? The equivalent unit can be deduced from the equation. So from this equation, we can see that the SI unit of energy will be joules and the SI unit of time will be second. So the equivalent unit of power is joule per second. So we can say that 1 watt is equivalent to 1 joule per second. So what is 1 watt? 1 watt represents that in 1 second 1 joule of energy is transferred. Now here we can see that there are two types of power. One is the positive power and the other one is the negative power. So what is the difference between this positive and negative power? Positive power indicates that the power is being absorbed by the element or the power is being used up by the element. Whereas negative power indicates the power is being delivered or supplied by an element. So for any electrical circuit, in any instant of time, power supplied must be equal to power absorbed. Now we can see here there are signs. Why? Because we all know for power supplied it is a negative power and for power absorbed it means positive power. So negative power supplied must be equal to positive power absorbed. Now here. So here this is the equation for electric power. So now we are going to derive the equation for electric power from the equation for general power. So electrical power will be equal to electrical energy over time. So what will be the expression for electrical energy? We can deduce it from the equation of voltage, which is V equals to energy over charge. So energy will be equal to V times charge. So we are going to now substitute this expression in the energy. So now electric power will be equal to V into charge divided by time. And we all know charge over time is current. Therefore, electrical power can be written as voltage times current. Now, as we all know, power and energy, they're related. Therefore, we are now going to deduce the expression for energy. And the expression for electrical energy is electrical power times time, which is equal to VIT. So now we are going to look at two different cases, case 1 and case 2. So in case 1, we are seeing that the 3 ampere current is flowing from the positive sign or the positive terminal to the negative terminal of the component. Whereas for case 2, the current is flowing from the negative terminal of the component to the positive terminal. Now, what is the difference between these two cases? The first difference is obviously in the direction of the current flow. One is from the positive to the negative and the other is from the negative to the positive. So as the direction of the current flow changes or reverses, there is a difference in power. So when the current flows from the positive terminal to the negative terminal of any component, that means that when the current is entering to the positive terminal of the component, then the power is positive power. Whereas when the current is entering through the negative terminal of the component, in case 2, it is entering to the negative terminal, so it is negative power. And we all know from previous lecture that the positive power means the power is being absorbed or it is being used up, and negative power indicates, that is in case 2 it is negative power, this indicates that this component is actually supplying power. So for case 1, power is consumed or dissipated, and for case 2, the power is being supplied as the power is negative. So we all know the active components supply power. Therefore, active components as they supply power, so they provide negative power. For example, power source or any battery, they provide negative power. Whereas passive components like resistors, they use up the power or they dissipate power, so they actually provide positive power. Now, for any given circuit, in any instant of time, the sum of power will be equal to 0. So what does this mean? This means that when we add power, that is power absorbed and power supplied, it will give us 0. Why? Because we all know the two values must be equal. So if power absorbed is plus 5 watt, then the power supplied must also be minus 5. So when we add 5 and minus 5, we will get 0.